So the following video is going to illustrate how to use correlation coefficients in SPSS. Before we get to the program itself, let's talk a little bit about correlation coefficients and what they do. So the definition from our textbook says that a correlation coefficient is a numerical index that tests the relationship between two variables. In a couple of seconds, I'll go over what this index means in detail. Before we get to the index and what it represents, let's talk about the hypothesis that we're going to use to test this in SPSS. So the hypothesis that we're using is, as an individual ages, they are more likely to remain in the same home for a longer period of time. Please note this is a directional hypothesis, meaning that we're hypothesizing that this variable changes another variable in a specific manner. So as age increases, the number of years that you're in the house also increases. You can also say something like, as age increases, the number of years that you've lived in the same house will decrease. Now that doesn't make very much sense, but what distinguishes a correlation coefficient hypothesis from other types of hypotheses is that we're actually hypothesizing a direction between the variables. In using the data set that we're using for this class, we can pull out an independent and dependent variable from this hypothesis. So the independent variable that we're using is age, or Q66, and the dependent variable that we're using in this hypothesis is the number of years you lived in your home, or Q27. Now Q66 and Q27 respond directly to the Santa Barbara Donor Project database. So this is a survey of Santa Barbara residents and those people who've donated to political campaigns. Before moving on to the program itself, let's talk a little bit about the correlation coefficient. So I'm going to discuss both direction and magnitude of correlations. So SPSS will allow you to assess this Pearson value, which is also known as a correlation, but this Pearson value will tell you two things. It will tell you about the direction, and it'll tell you about the magnitude of the relationship between your variables. So Pearson will always be between -1 and +1, and if we were just looking at the sign of that value, whether it's negative, whether it's positive, that tells us whether or not the variables are indirect or directly related. So here in the first row, if you have a negative Pearson value, what that shows is that you have an indirect or inverse or negative relationship. And the interpretation of this is, as the values of your independent variable increase, the values of your dependent variable decrease. So this relationship is in fact inverse. If you have a positive Pearson coefficient, you have a direct or positive relationship, and the way that we interpret this is, as the values of your independent variable increase, the values of your dependent variable also increase. The other thing that the Pearson value is able to tell you is it's able to tell you the magnitude of the relationship, or how strong the relationship is between the two variables that you're looking at. So with this, what we're going to be doing is we're going to take our Pearson value, whether it's negative or positive, and we're going to take the absolute value of that. So our negatives turn to positives. By doing so, we can say whether or not we have a weak, moderate, or strong relationship. So if the absolute value of your Pearson falls between 0 and 0.3, you have a weak relationship. If the absolute value of your Pearson falls between 0.301 and 0.6, we have a moderate relationship. And if the absolute value of your Pearson falls between 0.601 and 1, we have a strong relationship. So now we're going to move on to the program and actually do this. But before we actually go into the correlation, let's talk about what these variables look like. So I'm going to do a quick frequency look at these two variables. And if you remember back to the slides, I'm using Q27 and Q66 as the two variables in this data set. So 27 is how long have you lived in your present home, and Q66 is what is your age. Now these are two interval ratio variables, so they're going to be pretty big frequency tables. If we look at just the minimum and the maximum, the Q27 has a range going from 0 to 90, so a respondent has lived in his home for 90 years, and a respondent has lived in his home for 0 years, and age ranges from 29 years old to 98 years old. Now we can look at the actual frequency tables and see, right, that these are both interval ratio. At this point, we can go ahead and calculate the Pearson correlation coefficient. To do so, we go to Analyze, Correlate, Bivariate. And here, what we're going to do is we're just going to put the two variables that we're interested in the variables box. So Q27 is the first, and Q66 is the second. There's no other separate box to put this second variable in. You put them both in the same box. The Pearson correlation coefficient is the default. It's already checked. And because we're hypothesizing direction, what we're going to want to do is we're going to click one-tailed test of significance. After you've made that change, you're clear to go. You click OK. And the output gives you this. This is the correlation matrix. Now, as you add more than two variables to this matrix, this table will get bigger and bigger and bigger. But there's a couple of things to note here. First, this table is a mirror. If you look at the diagonal squares of this table, they all will say 1 for Pearson correlation, and that's because they're comparing the same exact variable to itself. So this cell here, which I'm pointing to with the cursor, that's Q27 related to Q27. This cell here is Q66 related to Q66. So those are perfect correlations. It's a very strong relationship just because they're the same exact variable. We have a correlation of 1. What we're really looking for is this cell. So this is the correlation between Q66 and Q27. So that Pearson value is positive, and the Pearson value falls at 0.401. With this in mind, we can say that the relationship is direct, which means as the values of age increase, the values of how long you've lived in your house also increase. So we know that because of the positive sign. And we also know that this is a moderate relationship because it's 0.401. So it's not small enough to be weak, but it's not big enough to be strong. The last thing to know about this matrix is that if you look at the other corresponding cell on the other side of the table, it's the same exact thing. Correlation matrices are mirrors on themselves, so you pretty much just have to read either the right diagonal of the table or the left diagonal here below.